In this video, we'll look at using the standard normal curve in a different way. You would use it in reverse if instead of being given a z-score and being asked to find a percentile, you were given the percentile and then asked to find the z-score. The work is similar. You'll still start by drawing a normal curve, shading the area that you're given, labeling the mean, standard deviation, and then identifying with a variable the unknown boundary value that you're looking for. You can either use Table A or you can use your calculator again to find the solution we need, and then finally you'll answer the question in context. Here's an example. High levels of cholesterol in the blood increase the risk of heart disease. For 14-year-old boys, the distribution of blood cholesterol is approximately normal with mean 170 milligrams of cholesterol per deciliter of blood and standard deviation of 30 milligrams per deciliter. What is the first quartile of the distribution of blood cholesterol? So remember that quartile means a quarter or 25%. So we'll start by sketching a normal curve and shading in the bottom 25%. Then we will either use our table or our calculator and we'll get the appropriate z-score of negative 0.67. If you're using the table, this time you'll look within the table for the closest thing you can find to 25%, which is 0.25. The closest thing we can find is 0.2514. And then you'll look out and up and identify the appropriate row and column, and that's where we're getting the negative 0.67. You could also use your calculator, and again there's a video there in your notes on how to do that. Once we know the z-score, we plug that into the z-score formula along with the mean of 170 and the standard deviation of 30. And then this time we'll be solving for x. We'll be solving for that cutoff value. And when we solve for x, we get 150. So to answer our question, the first quartile of blood cholesterol levels in 14-year-old boys is about 150 milligrams per deciliter.